Right, in the second video for this week, we're going to extend our Doom Scroller scenario. And we're going to update ourselves with the following knowledge. Let me read it out loud. New evidence has come to light that the viable red blood cell count is less important, zoom in a bit, than the proportion of non-viable cells. In fact, any sample in which there are more than 20% non-viable cells can be interpreted as a positive test for the virus. Your new task is to count the number of positive results identified by a non-viable cell. I need to rewrite this. Non-viable cell proportions greater than 20%. Okay. Okay. Let me just unpack that. You are going to need to not only count viable cells now, you're going to need to count non-viable cells, and then you're going to need to calculate the ratio of non-viable to viable, and that's the number that I'm interested in. And any time we see in an image a ratio of non-viable to viable greater than 20%, we're going to interpret that as a positive result for the Doomscroller virus. And I want to count how many positive identifications I can make in my set of 100 files. Okay, so the important thing to note here is that I've already got everything I need in my hemotools.r. Okay, there was the count viable I used earlier. There's another function called count non-viable, but there's also a final function here called proportion non-viable, which actually uses both of those functions above. Okay, so I'm only actually going to need to use this proportion non-viable. Okay, how am I going to do this? Well, I'm going to start where I left off from last time with this script for making viable counts. I'm going to create a new file. I'm going to save this as extension. And I am going to completely copy my script from the first part of this chapter. So I'm still going to unzip everything. I'm still going to process all the images. I'm still going to have a results vector, which I'll instantiate with nothing. But here's the difference. Instead of looping over every file and counting the viable cells in each, I'm going to replace this function with, I forgot what it's called. Let me run this one line again to source that. Right, it was the proportion non-viable. Okay, so let's do that. Proportion. There it is. All right, and it's again going to take an image path, so I don't need to update anything else. Then I can unlink this, and then what I'm going to do is I'm not going to print out the results. I'm just going to, in fact, I'm going to print out, print out results. Okay, let me source this. Let's run it all. This will take a while because actually it should take double the amount of time it took for my first part, because I'm running two functions now. On every file I'm doing two things. I'm counting the number of viable cells and I'm counting the number of non-viable cells. That's the blue cells. So I'm going to be patient and I'm going to wait. Don't be tempted to click off and go and do something else, or be frustrated that it's not working. If you can see that red stop sign in the top right, it means it's working. And here I am. It's done it. It's printed my results out. And so what you're looking at here, every single, so there should be 100 numbers here. Each one of these numbers represents the proportion of non-viable cells in each of those images. So this is 15.6% of the cells are non-viable, 6.31, blah, 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 blah. And I want to count, to answer my question, how many of them are greater than 20%, I'm going to need to count every time I see a value. Wait, let's find one. There's one, 22, 20, 22 again. So I need to count the number of numbers greater than 20 in this list. Now, I'm not going to tell you how to do that. However, I am going to tell you how you can find that out yourself. Let's have a look. Let's have a go. You know what I'm about to do. And I want you to do this yourself. I'm determined for you to do it this week. The question, you need to get the question right in your head, right? So when you're typing anything into ChatGPT or Google, be as specific as possible. So R, full stop. That'll mean it knows it's dealing with the R programming language. I want to count how many values in a vector are greater than 20. I've been very, very specific. Hit enter. Okay, it's giving you a bit of code, and actually it's giving you the answer. That will work. I know it will work because that's the solution I used. So make sure you can understand that. I'm going to blur this out. I'm that mean this week. I'm going to blur this out so you can't see the answer, but you can type this in to ChatGPT and find out for yourselves. Okay? If you're still struggling, contact us on the workshop channel in Microsoft Teams. That's it for this week, guys. One final push next week, and we are done. Well done, everybody, for sticking through to the bitter end. Yeah, that is a great. I've really enjoyed this week. I'm going to stop talking now.